the big three. Not one, not two, but three crucial elements of managing resources in a class in C++. Hi, my name is Spencer Hanson, and I'm here to talk to you about one of the members of the big three, the assignment operator. The big three, not to be confused with the Miami Heat basketball team, big three, is really important when dealing with dynamic memory. Here we have a class array, and its size, it's the current number of elements it holds, the capacity, the maximum number of elements it can hold, and then the array itself, which is filled with integers. Down here we have the constructor. We initialize the size to be 0, the capacity to be some default capacity, and then data, we initialize that to be a new array of integers at the default capacity. Notice that we use the new keyword right here. That tells us that memory is being allocated dynamically. This is a little bit different in that the user can control when the memory is created and when it is ultimately destroyed or deleted. But with this, it comes a lot of responsibility. Here in the constructor, we are effectively creating this. But at some point in our program, we're going to make sure this memory gets deleted. This is often done in what we call the destructor. The destructor is one of the members of the big three. It's kind of set up something like this. An array that. Okay. Inside, we will make sure to delete the data of that array. This delete uses the special brackets, and that it is specifically for an array. We're going through index by index and making sure that they all get deleted. Now down here, we need to make sure that we also set data to null PTR. This is to ensure that we don't get bad access. What I mean by that is that we don't accidentally try to use something after it has been deleted. So, once we finally delete this data, we don't want to accidentally access where it was at one point. We want to ensure that we're not going to get bad access at some point in our program, so we set it equal to null PTR. So, with the big three, if you need one of them, you're likely going to need all three. We've kind of just shown here that we are going to need the corresponding delete keyword when we use the new keyword. So, since we have one of the members of the big three, we're going to need the other two. For the sake of this example, I'm just going to focus on the assignment operator. So, the assignment operator is used when an instance of this class has already been initialized. So, for example, you may have an array A1, right, in this case, and then another array A2. At this point, both of them have been initialized, correct? And then now, let's say we want to assign what A2 is equal to A1. We're using that assignment operator right there. If we wanted to instead copy it in to A2, it would look something like this. So now, this is when it is being initialized. So we don't need to delete anything that is already inside of A1. Notice when we use this constructor, we're using the new keyword right there. So, but this, we won't actually use this constructor, we'll use the copy constructor. Now let's jump into the assignment operator. The array, reference operator, equal right there, and then array, should be a const array. Const array. So I chose to call it RHS because effectively this is the right-hand side of the assignment operator and this will be the left-hand side. This is what we will be assigning the value of the RHS to. Okay? So this is our pretend like these are what we have inside this array, so we're going to use. So before we can do anything, we need to make sure that we delete what is already there. So we're going to use that delete keyword, much like we used in the destructor. So we're going to delete everything that is in data because we want the contents of this array. We will assign size equal to RHS dot size. Assign the capacity equal to RHS dot capacity. And then data will now be equal to a new integer array of, since we just assigned it the RHSA capacity, it's fair game to use capacity right here. Just like that. So notice that we've used the new keyword right there, so we're dynamically allocating memory again. However, we haven't transferred all the contents of this right-hand side array over to the left-hand side. So we're going to need to use a for loop down below to individually take each index and take it over to the left-hand side. I'll write that out for you real quick. So we have a for loop, int I is equal to 0, I is less than the size, and then plus I. So data at index I is going to be equal to, or being assigned to, the RHS dot data at the same index. Close the loop. So now we've effectively transferred all the contents from the right-hand side over to the left-hand side. But we notice we have a return type up here. It's an array reference. So we're going to return this pointer. This is used when we're trying to refer to the current class we're working with. So we're referring to this side over here, the left-hand side, but ultimately the inside the class that we're currently working with. So everything looks good up until this point. However, we forgot one very important thing: self-assignment. What I mean by that is let's say, for example, we have an array A1, right? And then we try to take A1 and assign it to itself. That's fair game in a program, right? However, if you look closely at what we've done inside of our assignment operator, this would actually cause quite a bit of issues. So the right-hand side and the left-hand side would effectively be the same, correct? Because A1 is on both sides. But we were deleting the data from A1. So everything that's inside there. And then when we tried to go over here to grab the contents and transfer it over, we have deleted everything already. So we need to make sure that we're not assigning it to itself. So we need to do what we call the idiot check. We're going to, at the very beginning, we're going to take an if statement, and if this, that would be the left-hand side, right, is the same as, or it's equal to, the right-hand side, then we're going to immediately return the this pointer. Nothing needs to be done, as we already have all the contents over there. We're just effectively trying to transfer the same thing to itself, which is pointless. So it's great to just get out of there as quickly as we can. But it is very important that this is included. It's simple, but otherwise everything would be deleted before we could actually push it over.